What's up, everybody? Welcome back to another 3D Hangout. Got myself Noe Ruiz here. I'm a designer at Adafruit.
Hey guys, I'm Pedro Ruiz, the creative tech here at Adafruit, and every week we're joined here to talk about 3D printing projects, news, we go over CAD tutorials, we take a look at some slice settings, all the cool, crazy, nitty-gritty stuff that happens in the world of 3D printing. Yeah,
through all of it, we'll keep on printing. DIY electronics and 3D printing. Let's take a look at what's on the show.
That's right, every week we have a lovely assortment of segments. We first start off with what are you prototyping? And we'll take a look at some of the behind the scenes at some future projects we're working on.
That's right. Then we'll take a look at 3D news.
That's right, every week we scour the net for the most interesting stories happening in the world of 3D printing.
Weekly video.
That's right, every week we come out with a cool 3D printed project featuring sometimes electronics from Adafruit.
Mostly.
And
then our Layer by Layer segment.
That's right, it's where we take a look at some of the slicing tutorials, some of the CAD techniques, some of the cool work-ins that happen while designing.
Yeah, that's right. Okay, so we're going to start it off with
coupon code. That's right.
Okay.
Okay, this week's coupon code is Trophy. Use the discount code to get 10% off in the Adafruit shop. You can get yourself some lovely assortments of 3D printing accessories or some electronic goodies for your next project. Expires at 11:59 p.m.
Yeah, so check it out. All right, first up.
What are we prototyping?
Yeah,
all right, so we got some cool bottle nipples here for the top of the bottle for the little sister syringe from BioShock. So future project that we are working on. These are pretty cool. They're made in NinjaFlex. You made these, Noah, using the profile sketch tools.
Sure.
Just lofted those. I was just gonna like draw a sketch of this and revolve around it, but you came out with a better way to do this. So we'll talk about that.
Sure.
And when we release that episode. Also been doing some polishing techniques for the main body of the syringe. We found out that the 3 buffs and brushes available in the Dremel polishing kit are the best for this. So we got the little white abrasive brush. We got this used to be the darkest one that comes in the kit. It's the 320 grit buff and the 280, I believe, the 240 buff. So it's basically the hardest one, the softest one, and the little white one of these that come in the kit. Also, the polishing compound gives it a very nice contrasting tone to the overall body. Definitely check out when we release that project. Another cool thing we found out too, printing with the Type A Series 1 machine, is how big we can actually go if we set things on the bed diagonally. So this is 434 millimeters big, all one piece. So pretty cool. Definitely check back when we finish this project.
Yeah, I want to talk more about that project, but we'll leave it for other weeks because
there's plenty
we're going to have to
talk about.
span that one. Yeah, I'm working on another cosplay project as well. This is the first piece that I have. This is printed on our Orion Delta printer, and it's really perfect piece for that because if we were to print it flat like that, I guess it would work, but you would have to, you would have to have some support material for this. It wouldn't be as sharp as it would if you printed it straight up. When this was printed straight up, it's got a cavity in the center there for wiring to go through, and then there's another top piece that's going to come here. There's a lot of detail here, and it looks really, really nice. There's no finishing done to it, and this is printed in translucent or opaque green material that we have in the shop from Ultimachine, so that's pretty cool. So this is going to be a weapon, like a handheld pistol with a blade on it. It's from the web series anime Ruby, and this is Lyran's Stormflower weapon, which is pretty cool. So it's just one piece of it so far, and we'll be sharing throughout the next coming weeks more of it.
Yeah, this is a really
multi-part. Multi-part multi-part project. Very fun, cool one. Yeah, I think that's going to do it for this segment. We got a lot of stuff we wish we could share, but we can't share it all because then we'll have nothing
run
for
out
the
of
next.
Stuff. Yeah. Let's go ahead and jump into some news.
All right, news time. First up, we got a very awesome update from our friend in the UK, Mr. James Bruton from X Robots. So if you haven't followed James, check him out at youtube.com/xrobots. He is working on very cool projects. He's got 4 going on right now. He's got the R2-D2 project, which is fully 3D printed. It moves. You can control it. wants to do lights and all sorts of cool different things. But the main point of this one is that it's all 3D printed. Typically, you would make it with other materials, wood and steel and metal frames. But this is super light, 3D printed. And James Bruton is now releasing his CAD files on GitHub, which is a really good idea because he's still working on the files. And it'd be nice for people to split them up differently for their printers to help other people out. So I think it's definitely one of the best way approaches to it. Normally, he would give out his CAD files exclusively to his Patreon supporters, but this time he wants everyone to participate in this project because we think it's a really cool and big project. There's lots of CAD files to look at and admire. But most of it is printed in PG. Yeah, they're 1.2 3D files. So this is solid solids. The original solids are available, so you can split them up. And he does quite a good engineering task of splitting everything up, keeping files sort of separate from each other, so that you don't have this giant file that you open up and everything's there. Everything's sort of segmented, which is the right way I think to do it, at least in this package. And it's cool. It's all free, open source, using open source stuff. So we might as well release it open source.
That's right. Again, build your own R6 droid with the plans available on his GitHub page.
That's right.
Definitely check that out.
Okay. Next up, do you want to look at the castle?
Next up, we got a
castle?
Giant princess castle.
This is a princess castle. All right. This is on Thingiverse. We saw it pop up, and we were like, wow, that's a pretty damn big castle. So tell me about the castle. Did the dad build this? What's going on?
Yeah, so this was an industrial engineer who actually helped out one of his co-workers build this ginormous, 675 millimeters by 514 by 342 millimeters. That's pretty big.
Pretty massive.
Give you some sense of that. This is 434, so it's a little bigger than this.
It's tall too, man.
So yeah, you can definitely print this in all black and make like a goth, castle out of this. This is 44 pieces. It took about 10 to 14 hours for each piece, and about 120 hours, which sounds a lot, but isn't really that much in our world.
2,600 grams of filament. That's definitely a couple spools, but it's definitely worth it if you want to build just an amazing project for your loved one.
Yeah, this is an awesome project to test out. Size.
Yeah.
In terms of going out and buying ones, you can definitely customize this yourself. Add anything other cool things you can't get in the store.
Yeah, you print yourself a new one. Yeah, so that's really cool. And the last thing is, couldn't find it. The reason why they built this is because they couldn't find it on Thingiverse. You just search on Thingiverse. Somebody's got to have made it. Well, somebody made it now.
Now you can't find it.
And it's cool that the engineer helped the dad learn SketchUp so that he can build it himself. But he also helped up, of course, to make sure that all the parts snap and that everything's going to print properly on an FDM machine. So yeah, good kudos to you, sir, Mr.
Now winning
Mariano.
Dad of the Year for
Mr.
this
Mariano.
one.
Okay, very cool.
And next up, we got a wirelessly powered PieBook.
Oh yeah. Let me see that. Wirelessly powered PieBook. What is that?
All right, so this is a Raspberry Pi Model B with a touchscreen that is charging a 1,000 milliamp hour battery wirelessly.
Using coils.
Yeah, just through a transmitter underneath the table.
This is a DIY transmitter, so he actually has instructions, and he's willing to help people out build this if you're having trouble with it. He's got all the parts listed out in his Thingiverse profile, and there's a very, very cool enclosure. When it's charging, he's got a UV LED, a purple LED that lights up, and you can see that the distance between how much you can charge is about 7 inches to 8 inches or so. That's really cool. Got a touch screen on there as well.
Has an interesting little flip, sort of like a flip case.
A little flip case. Is that in there in the video?
No, it's on it. Just the way the flip flips backwards instead of
cool.
frontwards like a
So
laptop.
Portable.
Little keyboard
nice
there.
Keyboard. We saw that one.
Okay, and as we can see here, the innards of all electronics. Pretty cool setup that he did for all the 3D printing to fit all the coils inside there. Very awesome case design, and the hinges are attached with some screws. And here we go, all the electronics on the inside all wired up. Nice big battery, beefy battery to keep everything going.
Yeah, he mentions that if you wanted to make this an easier project, you don't have to have the wireless capability. You can just have the battery charge or the battery power all the Pi stuff. It's very cool.
Yeah, so definitely check this out. It's available on Thingiverse. You can download all the files and make your own.
That's right. Okay, what's up next?
Next up, we got an animated cat ears.
Okay, so we've seen this type of thing before, but this is 3D printed. and it is available, our Arduino sketch that does the animation for the servos. So it's using the servo library. Very, very cool. It is...
this is by Russian Thingiverse user Oleg T, which shared this, all the sketch files for this. The servos are using 2 degrees of freedom to animate the interesting little effects that you got there. I really like the little scratchy thing there with the ear. The CAD files are available, which are basically all the mounts for the motors, or the servos.
That's right, yeah.
You can download these and edit these to, fit any servos you might have lying around. These are pretty cool. Really like the way that he designed all the mounts for this. Of course, little ear cups that go on there. Fantastic. All you got to do is dress these up in some fur, and you're good to go. Or modify these to turn these into a different type of ears.
Yeah, maybe you can make some wings or some fingers or something.
Some insect,
definitely
antennae. That'd be pretty cool.
Sure, definitely want to check that out. It's on Thingiverse. You can download it now. And we got a link for you in the description if you really want to check that out.
Yeah, next up we have a pretty cool gear generator.
Okay, gear generator. This is a sort of a web app. This is a website called geargenerator.com. This was developed by a gentleman who wanted to just have an easier way to make gears. So with this was built in JavaScript, and HTML and CSS, and you can change the parameters of each gear. So you can change the teeth, the number of teeth, the diameter, and the speed of the rotation. You can add more, subtract more. Very, very cool. It's a pretty powerful tool for...
really cool little simulator here, yeah.
And the best part...
You can export SVGs out of this, import into your CNC machine, or you can even extrude these out to make 3D printed versions of these.
And you can modify the parameters live as it's animated, which is pretty cool. Great use of CSS3 animations and JavaScript.
Yeah, you look at his page, and he has a track record of creating very cool web tool apps like this. Definitely check him out.
Yeah,
link is in the description.
Okay.
Next up, we have the most cutest, world's smallest drill.
Okay, let me pull that up here. Sorry to be a little bit slow on that, but here we go. The world's smallest drill, and it actually works.
Look at this little thing.
This is amazing.
Awesome. This is like made for hamsters to escape their cages.
Yeah. It is 17 millimeters tall, 7.5 millimeters wide, 13 millimeters long, using a 0.5 twist drill bit.
And they're using like a hearing aid battery, tiny little motor. You can cut to the pictures on the inside of this guy.
Yeah, sure. It's tell me what printer was it printed on, and
so
where
this
was it designed?
Ultimaker. He designed it inside of Onshape 3D. There's a three-piece drill design that takes about 25 minutes to print. And the reason it takes 25 minutes is because he's printing at 10 millimeters a second.
Which is when you go small, you definitely want to print small, slow. But I think even slower, you're going to get like this.
It might start getting melted. Yeah.
So amazing to print with such a millimeter,
And if this wasn't small enough, he said he's found an even smaller
he wants to make it even
motor.
Smaller motor.
So this is pretty cool. It looks like we're miniaturizing everything. This would look pretty awesome actually on the Amber 3D printer. It'd be all transparent. You could see all the electronic guts on the inside. Yeah. So very cool. Here it is on top of a New Zealand penny for scale.
Yeah, we think it's a penny. It looks like an American penny to us. But yeah, that's going to be it. That's the news, right?
It's the news for this week. Definitely check out all the stories on the blog, adafruit.com/blog, or is it blog.adafruit.com?
Yeah, blog.adafruit.com.
Search for 3D Thursday tag, and you can find all those there. They're also in the description for this video.
If you want to pick up some electronic goods that you just saw, you definitely can using discount code TROPHY.
That's right. A lot of the projects are using our components, so you can definitely check those out. Use 10% or use discount code TROPHY, 10% discount at checkout. Expires at 11:59 p.m. Doesn't work on software or the gift certificates.
That's right. Okay, now without further ado, we're going to go ahead and check out this week's project video. We'll be back in a little bit. Coming up, 3D printing a drone trophy. Adafruit's Dronie Film Festival is one of the first film fests for drones, and today we're going to build the trophy and 3D print the parts using bronze fill. We think this will be one of the best online film contests for drones, so we had to design a cool award with 3D printing and metal filament. Our creative director, Bruce Yan, created the artwork for Dronie, and Dronie is basically our friendly, cuddly gumdrop-looking character that really represents Adafruit's Make Robot Friends mantra. So I started by importing Bruce's artwork into CAD to create the basic shapes for building the trophy. The parts had to be broken up into pieces so that they can fit inside our rotary tumbler. So these parts are going to look really polished when they go through the tumbler, and if you haven't already, check out our video on polishing techniques over here. So when printing with bronze fill, you're going to want to have loose tolerances on your snap fit designs to compensate for expansion while printing. I sliced these parts with a bit more infill and outline overlap. Extra top and bottom layers help close off the surface, while more shells lets the surface withstand hours of tumbling. Now on to printing the parts. So large parts tend to be difficult to remove from the build plate, so I found it easier to use two spatulas, one to peel the corner and a second one to slide underneath. Printing at 100 microns on the Type A machine works really well, especially with bronze fill, and I set printing speeds around 40 millimeters a second to help retain surface quality. Some of the parts are of course easier to remove than others, so it's important to do it slowly and carefully. It can be a little dangerous, you could break the part or hurt yourself, so I tend to be pretty careful. These parts tend to come out with stringy bits due to retraction and oozing, but this can easily be cleaned up using diagonal flush snips and a hobby knife to get in between all of the nooks and crannies. I let the parts tumble for about 1 to 2 hours and use stainless steel screws as the medium. Using different size screws actually help polish the smaller details. The parts came out looking polished and have that bronze cast look. They're really shiny and it feels just like metal. I mean, the weight of this stuff is what makes it really cool. For making the prop bits, we actually used the Amber printer from Autodesk. These tiny parts are perfect for DLP SLA printers, and they came out with amazing detail in clear resin. To secure the tower piece to the base of the trophy, I used E6000 to bond them together. The bottom part has recessed fittings for the prop arms, and they just snap into place. The tolerances came out pretty good with an offset of 0.4 millimeters, which gives it a slight snap fit. A bit of E6000 adhesive will permanently bond these parts together. I used a clamp that locks so I can hold it in place tightly while I let the adhesive cure. For the propellers, we wanted them to actually spin, so I had to design it in several parts. The prop piece has a hole in the middle, so a studding can be inserted and held in place with the lock nut. The studding piece itself has a cool little cap on top, which really finishes it off. There's a cavity on the bottom of the prop arm for the lock nut to snap into, and we'll just glue it in place. And that's pretty much how we made the props freely spin. I thought it'd be cool to use magnets so the Dronie could come off the trophy base, and this kind of gives it a bit of freedom, which I think is pretty cool. And now we have Dronie, a 3D printed trophy in metal filament. So if you're thinking about using metal filaments in your next 3D printed project, check out this stuff from ColorFab. You can pick up some bronze fill and copper fill in the Adafruit shop, and you can even get yourself a discount coupon code on Wednesdays and Thursdays. Check the link in the description. Overall, we think this is a pretty cool trophy for a very special film festival. So do you want to win this trophy? All you gotta do is make something amazing with drones and use hashtag Dronie. More details are coming soon, so check the Adafruit blog and social accounts for more info. Thanks so much for watching, and don't forget to subscribe for more 3D printed projects from Adafruit. And until next time, I'll see you guys later. Remember to make, share, repeat. Bye everybody. Trophy. Dronie trophy. All right, so that was this week's project. Definitely really cool. Definitely check out Adafruit's social channels for more info on our upcoming Dronie Award contest.
Yeah, that's right.
Yeah.
So let's go ahead and jump into this week's layer by layer.
Alrighty, so we put this together in 123D Design, and I want to shout out our
creative director, Bruce Yan, for putting this awesome, cute Dronie together.
Yeah, he designed the artwork for Dronie and did an incredible job on supplying us with the angles and different profiles for him. And we put together 2 different tutorials on how we put together the artwork, or at least the 3D parts. So we got one on using artwork, vector artwork, SVGs, importing them into 123D, and then extrude them out,
doing
using
like
the revolve tool. And then we also use the measuring tool to make sure everything's scaled properly and measuring distances between objects. That's really important. So we got those 2. Check out our playlist, layer by layer playlist on Adafruit's YouTube channel if you haven't already. And in this particular one, we're going to take a look at how the snap fit parts are working. So this is our first copper fill printed project that uses snap fit parts. So the bottom actually has some recessed cavities, which is just a projection of the arms. And when I did that, I made sure that I created an offset, a positive offset, so that it would be 0.4 millimeters bigger than the actual arm, so that there's enough clearance for the thing to snap into. Now, when you're printing with copper fill, your filament's going to expand a little bit. Sometimes you get shrinkage, right? Well, this one you get expansion. So you definitely want to prototype and test to find out what your printer's nozzle is going to do and what your settings are doing, because like these are printed with more shells. Typically you would print with 2 shells. I printed this with like 4 or 5, mainly so that they would withstand the hours of tumbling. So that's why I have such a big clearance here. So let's continue on with the video and take a look at some different parts. Now you'll see the bottom of that.
So you use a projection to create that.
Yeah. And it's just 0.4 millimeters bigger. And then you'll note that the actual arm has a little connector nub, and that nub is what sort of connects into the head of the part. And you'll notice that the hole actually is a little bit taller, deeper than the actual connector itself, and that's because with the overhang, you're going to want to have that extra clearance there. Another cool thing is that you can add a chamfer to the hole so that it opens it up more and it allows the pieces to be really flush, so that there's no extra material sort of getting in the way. So I found adding that when I didn't have that chamfer, it just wouldn't close all the way. It would have a little seam that you can see. So that was a good way to make sure that that was nice and clear. Next up, the clearances on the propeller. The way that's working is it's got a hole in the propeller, and then we're using a studding that we printed on the amber. So when you're printing on the amber printer, which is a resin-based DLP SLA printer, the tolerances isn't that big. So here we're actually, the clearance here is just 0.2 millimeters. And to find that out, you can use the measure tool, which is up here under adjust, and you just click on the edge that you want. So you can see that one's at 1.4 and then 1.6 for the actual hole of the copper part. And there's the difference there is the 0.2 millimeters. And then the arm also has a hole in it, which we're going to get to over here in a bit. The little arm there also has a hole, which is the same as the hole for the propeller, because they're both copper fill parts, yeah? Mm-hmm. Yeah, so I'm just showing you guys here. You can use the measure tool to make sure that your openings and things and your radiuses are all the same for those 2 parts. And then the last piece that keeps everything together is a little wing nut, and if just by glancing you can see it's got quite a bit of clearance for the wing nut, and it's not because the amber print gets small or too big, it's because the expansion, and also it's...
So the metal filament is a little heavier. It's definitely heavier. So the overhang that happens is going to be more pronounced. Yeah, there's going to be more weight. It's going to droop down more.
So that's why there's a bigger clearance. It's a little bit more deeper than the actual height of the nut. And again, there's also a chamfer. Let me hide that real quick. There's a chamfer right there so that it prints. It tries to print good. You still have to clean it out and stuff, but
you're also accommodating for glue here too that we're using to stick everything together. So you got to account for those 2 things when printing or when creating your offsets and clearances for any snap together parts.
Yeah, and that's basically all the parts for it. It's pretty simple construction, really. And yeah, I definitely encourage you guys to check out copper fill if you're looking to make some pretty heavy metallic looking parts. We're still figuring out what cool things we can do with it and pushing it to its limits, and working really well. One of the things that initially I thought wasn't going to work was the putting the propellers through a rock tumbler.
And that turned out to work out pretty good. Sometimes when you leave it in a little bit too long though, it will definitely break on you. So we started figuring out what time limits are for such small, thin parts, which was about half an hour, I think, right, for the propellers.
That's right. So just a half an hour seems to work really well. And then every one of these parts were designed to fit the tumbler. So I made sure that I didn't exceed the dimensions that the tumbler would.
For ours, it was about 90 millimeters tall by I think 40 or 60, something like that. Yeah.
So that's why I had to break it up into little parts. That it's just more optimized that way because it prints with no support materials. That's really cool.
Yeah, tumbler is definitely the way to go for doing this type of polishing, because for doing the Dremel with this, I mean, there's just so many little parts in there. I mean, this would be a pain in the butt to try to get all the little crevices and things like that in, and you'd probably damage a lot of the sides and things like that. So the tumbler using number 2 screws, number 4s to get into the nooks and crannies is definitely the way to go.
Yeah. Very
So
cool.
yeah, this is an excellent use of. I think it's a killer app for all the metal stuff.
Yeah, make a
making
trophy.
statues, trophies, and of course the upcoming week. Some props to that require the copper
That's
or
cool.
the bronze.
Yeah, bronze and copper right here. They're both from Color Fab. Lovely folks from the Netherlands.
And if you haven't heard, they have brass fill actually coming out. Hopefully we get to test some of that out. So we'll be posting some cool behind the scenes sneak preview prints of that, so be on the lookout for that. So yeah, this is, I think, all the time we have for this week.
Okay.
We have some projects. We got some links for you guys that you can always check out if you want to see some more.
Sure. Let's take that out here. If you want to see more cool projects, not just 3D printing, maybe some wearables, we got tons of them on the Adafruit Learning System. That's where all of them live.
That's right, step-by-step instructions, all of the circuit diagrams, everything you need to know to get your project up and going.
Demo sketches, libraries. All right. Requisites. You can come and share your projects with us on our show and tell show. Adafruit has a show and tell show every Wednesday at 7:30 p.m. Eastern Time. You can check that out on the Google Plus page for Adafruit.
That's right, we're there every week. Come on in, say hi, show off your cool 3D print projects. If you made one of our projects, show it off. If you modify it, let us know what you made. We'd love to see it.
Free prizes.
That's right.
3D Thursday on the blog every Thursday. It's 3D Thursday. It's where we share all the stuff that we talked about today and more. There's more stuff there.
Oh yeah.
Not all of it made it in the show.
There's too much stuff. Yeah. Just search for hashtag 3D Thursday.
Or
find
just
all that.
Yeah, just go to the blog on Thursday.
Yeah, there you go.
Every day. You should go every day. And then you can follow me and Pedro on Twitter. I'm Ekin.
I'm Video Pixel, and of course follow the main Adafruit account.
Yeah, on the social channels.
Yeah.
That's right. Well, folks, this is where we say goodbye. Thank you for watching. Drop us some comments if you want to see some cooler stuff. Let us know. We want to hear from you.
That's right. As always, what is it? Make, share, and repeat.
Make sure repeat. That's the thing I say at the end of the show. One last thing, though. Don't forget about our coupon code.
That's right. Trophy, 10% discount code. Apply that during checkout. You get 10% off.
That's right.
Expires at 11/59. Doesn't work on gift certificates or software.
Yeah, get on it. If you're looking to get some cool stuff,
Right.
check it out, adafruit.com. All right, folks. Bye, everybody.
See ya.